Hey guys, so this is the video about each of the properties. So if you follow along with me as I talk you through it, that'd be great. Make sure you're writing down pertinent information that I'm writing on my board, and you're also, when I tell you to, thinking of an example of your own that you can put. So the very top tells us properties tell us that two equations are equal despite looking different. They allow us to regroup or change something about the equations to make it easier for us to solve. So you probably remember most of the properties names. Let's just review what exactly we are looking for when we look at the commutative property first. So the commutative property, remember, it changes order. So we will see a change in order, meaning who is first, who is second, who is third in the equation. Okay, so on one side of the equal sign, numbers are going to be in 1, 2, 3 order, and then on the other, they're going to switch order. Okay, so remember, we use the root word of commute, which means to move back and forth. Okay, so remember we said, like, we commute to school, so we move to school and then we move back to school. Okay, I'm going to give you two examples, and I want you to think of one on your own. So my first example for you is going to be with letters each time. So A plus B equals B plus A. Just notice that the numbers are moving, okay? 3 plus 2 equals 2 plus 3 would be a numerical example. I want you to think of one example on your own of the commutative property, and I want you to write it where I place that star. And again, you can pause the video if you need more time to write an example. I'm going to keep going. An example of a multiplication sentence for commutative property would be A times B equals B times A. Notice that A is first, but A is second here. B is second here, but now it's first. So they're just changing order. A numerical example would be 3 times 2 equals 2 times 3. Changing order, but still the same product. 3 times 2 is 6. 2 times 3 is also 6. That's what we are looking for in properties. Change the order, doesn't change the product. And again, pause the video to write one of your own. Okay, we're going to move on to the associative property. Associative property changes grouping. Another root word example here, we see associate. So you can remember it by who's associating. One day maybe you want to associate with the first number, but the next day you're going to associate with the last number. So you're going to change the parentheses or change the grouping. Now we always want to remind our students that not every time there are parentheses, it's associative. Not every time. Okay, sometimes you might see parentheses in commutative, but there will always be parentheses for associative property. An example of that would be A plus parentheses B plus C. So notice that B and C are grouped. Then A and B are grouped here plus C. Okay. So it's just like it's shifting, the parentheses shift down or shift up. One thing to make sure you pay attention to is that the order does not change here. Okay, A, B, C, A, B, C. A, oops, A, B, B, and C, C. Order does not change. An example with numbers would be 1 plus 2 plus 4 equals parentheses 1 plus 2 plus 4. And then come up with an example of your own. Again, you may pause the video before you move on. Okay, the multiplication example is pretty much the same thing. A parentheses BC equals parentheses ABC. So it goes in ABC order on both sides of the equal sign, but first BC are grouped and second A and B are grouped. Okay, another example. 7 times 3 times 2 equals 7 times 3 times 2. And then again, think of one example on your own to place underneath. The identity property. Okay, so the identity property, it stays true to its identity or itself. We want to think of like a number starting as 7 and nothing is going to change it. Whether it's multiplied by 1 or added to 0, it's still going to be 7 on the other side of the equal sign. So my number here is, with addition, we're going to add 0, and its identity is not going to change. And with multiplication, we're going to multiply by 1, and its identity is not going to change either. These are called the identity elements. So an example of that would be a plus 0 equals a. 0 comes in and tries to change a, but it is not successful. 3 plus 0 equals 3, another example. Okay, go ahead and where the star is, try to write your own example of the identity property of addition. For multiplication, it would be a times 1 equals a. 1 tries to come in and change a's value, but it does not. A stays true to its identity. A. A numerical example, 3 times 1 equals 3. 3 stays true to its identity, stays itself. Okay, try to think of one example for the identity property of multiplication. Again, please pause the video so you have enough time. The inverse property states that every number has an opposite, okay? So if we are talking about addition specifically, a, and what would a's opposite be on the number line? Well, negative a, because a and negative a are 0 pairs. They get me 0. They are inverses of each other. And for multiplication, we talk about the reciprocal as the inverse. Okay, and so I'll show you examples of that right now. For addition, a plus negative a equals 0, the inverse property. And then numerical would be 3 plus negative 3 equals 0. Think of one example on your own. Okay, multiplication, the examples would be a times 1 over a, which is the reciprocal, right? Because there's a little understood 1 underneath a. Those are reciprocals or inverses of each other, equals 1. And if you wanted to look at it with numbers, we could say 4 times 1 over 4 equals 1, or 3 over 4 times 4 over 3 equals 1. So even though that 1 isn't written under there, under that 4, it still is the inverse property of multiplication, okay? Because it's still 4 and the reciprocal of 1 over 4 is still the inverse property. Okay, so go ahead and think of one, hopefully you have space, one more example for the inverse property of multiplication. All right, the 0 property. This is the big one. Any number multiplied by 0 is 0. But look at this big X. This is a big reminder that this never is with addition. Never, ever, ever. Okay? Some examples for multiplication. A times 0 is 0. Any number times 0 is always 0. Okay, and then think of one example on your own there. Lastly, we have the distributive property. So the distributive property says that a number outside of the parentheses gets distributed to the numbers inside of the parentheses. So we usually call this distributive property of multiplication. So we're going to skip over addition because we are multiplying. Remember, this is the diving dolphins. Oops. Diving dolphins, and you're going to see why in a second if you've never heard that. So if we had A times B plus C, what is that going to look like on the other side? Well, we're going to do our little blue diving dolphins, and the arrow means multiplication. So we're going to take A and multiply it by B, so AB, and then we're going to go back to A and add it to the product of A times C, which is just AC. Let's look at that with some numbers. So we have 3 times x plus 4. Okay. So 3 times x. What does that become? Well, we don't know what x is, so just 3x. Then we go back to the 3 and multiply it by the 4. So we would say plus 3 times 4. Can we simplify that further? Of course, we have 3x plus 3 times 4 is 12. And that would be your final expression. Because there's no equal sign, you can't simplify it any further. So you would add up with 3x plus 12. Alrighty. So on the back, what I want you to do is flip over. Okay, there are 10 problems for you to do, and then there are, at the bottom, 2 distributed property problems. Make sure that when we're using it, the distributed property, say it was 7x minus 1. When we distribute that 7x out, okay, that's obviously 7x, but then we go back to the 7, make sure you distribute the 7 out to this whole number in here. Okay, that sign, that negative sign, equates to the 1, so it's negative 1. So 7 times negative 1 would be a negative 7. Okay, so that's my little hint for the bottom part on the distributed property. But on the independent practice, each property that's used on the front, there are 10 of them, they're all going to be used once on the back. So I need you to write like commutative property of multiplication or of addition. All right, go forth and best of luck. Raise your hand if you have a question, and I will check it when you're done.